Okay, so let's begin. I'm converting my Gcode into, my Gerber files into Gcode using the software called Flatcam. The one that I'm using is Flatcam version 8.991 beta. There are newer versions out there of Flatcam, but I prefer using this version because the new ones add additional Gcode into there by default. One particular one is called toChange, and that causes issues. I just didn't want to deal with that, so I'm using this version. Okay, so we go File, Open, Open Gerber. So for the first thing we're going to do is going to do the isolation routing. Um, so the thing that we're going to open is the top layer Gcode, Gerber file, which is this one. And this is what we got. We want to move this close to the origin as possible to there, to this crossover here. So click on it, left click on the file, the object, right click, move, click on the object again, and then this blue square represents it moving. So I'm happy there, so I'll just click there, done. Now, double click on the Gerber file, and this menu will pop up. The 2 diameter, we're going to calculate it, so go to Tool, go to Calculators. Okay, so this is the bit that you'll be using to do the cutting of the isolation route. The tip diameter we bought is 0.2. The angle, which is 30 degrees. This information is typically provided to you from the seller or engraved in the bit. The depth. So how deep do you want this thing to cut into? For us, we just want to cut 0.1 millimeters, and that's fine. And the 2 diameter value comes up. That's that. Good. So we're going to copy this. We go back to project, double click on our top layer Gerber. This menu pops up, and put that in there. But before we do that, we probably should do some checks first. So go to Edit, Preferences. These are my settings. I'll just pause here for a couple of seconds so that you can copy it down. I use millimeters because that's my machine setup. And that's about it. Okay. So back to here. So we put the 2 diamonds here. The passes. Some people recommend 4 passes. Based on my experience right now, I would say maybe 2 passes would be sufficient. Pass overlap. This is how many times that the thing will, the bit will intersect with the routes. I typically would say 20% would be a good answer for that. You can do more. The minimum that is recommended is 10. The next thing we're going to do is click combine. So what this combine does is basically combines your 2 passes into one file rather than 2 separate G codes. So that's fine. Scope all and then generate isolate geometry. You see all these red lines everywhere. So that's where it's going to be cutting. Okay, so we're going to be cutting the depth of 0.1 millimeters because this is a negative value, so you have to put negative 0.1. I just ignore multi-depth for the moment. The travel Z is just basically how far above the material it's be traveling on. I put 2 millimeters to be sufficient for a PCB. And move is when it finishes doing its cut, where how high does it want to be lifted off the board. Put this as 5, that should be enough for me. And I think based on everyone's experience, 5 should be enough. X and Y was 120. The Z at 60. Spindle speed is how fast the spindle is going to be moving. I'm going to put 1000 RPM because that's what I choose. Some machines you don't have that option. Mine does. I'm going to put at 1000. And that's it. Generate CNC object. So you can see these blue lines is where the thing, the thing will be cutting on. We're happy with that. We save the CNC code. You can view the G code by clicking here, so you can see what it's doing. I'll just click save, and we'll just create a new folder. So we're going to pop everything in there. So CNC 0.1 depth, 0.2 bit, and we're gonna say that is 2 passes. So save it in there. I'm happy. Okay. Go back to projects. Now we're gonna do the drill holes for the pads. We'll go to File, Open, Open Exelon. Go to here, here. Okay. The one that we wanted is this file here, Gerber drill path. That. Now we need to move this as well so that it aligns to here. So click here, move here. So this is where I want it to be, and there we go. Now that's where the holes are going to be in there as well. For me, I don't need these holes here and here. I'm going to remove them. The way you do that is you right click, edit. This menu will allow you to do some changes. Actually, I should probably close editor because I'm not going to do it here. No. Drill path. And then right click, edit. This menu pops up. Great. So I don't need these 4 crosses, these 4 holes, sorry. So I'm going to click delete drill and just click on these ones. And then press delete on the keyboard, press delete on the keyboard, press delete on the keyboard, and press delete on the keyboard. And you can see that the count's going down. That's good. So we only got 8 holes to drill, which are just these big 4 ones. And then once that's done, just right click, close editor, and save your changes. Yes. Okay. Now the original drill path is still available, so we're going to right click, we're going to delete that. We don't need it. And that's it. Now we haven't done anything in terms of converting to Gcode yet. Now we're going to do it for the drill path. So double click on the drill object. Okay, the depth for this one will say negative 2 millimeters because we're going to go create holes. Travel Z, we're going to leave that as default and move. So this one is the reason why you'll see in the video that my bit break, because I put that 0.5, whereas this is meant to be 5. Feed rate 300, that's fine. Spindle speed, I'm going to put 1000 like before, and then create Gcode, and that's it. Okay. The bit that I used this was at 0.7 millimeters in diameter. And then create Gcode, and that's it. We're going to save the CNC code. You can view it as well if you want to. I'm going to save it. So this is where it's going to be, and save it here. That's it. So we've got 2 of those G-codes. Now we need a 3rd one, which is actually cutting the PCB out. Some people like to use the outline method, but I prefer doing it this way. So go to Tools, Cut Out PCB. The bit that I used for the cutting was at 2 millimeters. So just 2. The depth, negative 2 millimeters. Multi-depth, just leave that as default. Gap size is how thick the branch is going to be. I recommend 3. Margin at 0.1, and that's it. The gaps is basically where you want the tabs going to be. I like to use 4, and then create generate rectangular geometry, and there you go. So basically, it will start cutting here, here, and then here, 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 here. Okay. Once that's done, you go back in there. And then generate CNC object. So -2, 0.6, 2, 15, 120, 60. Actually, no, end move for this is going to be 5. Yep. Okay. That's it. And generate CNC object. There you go. And then save CNC code, save it. And basically you got 3 of your codes that you needed and save here on my left side. You can see it here. 2 passes. And basically you just transfer this to the computer you'll be using to run Candle, and we'll go from there. Okay, so we're gonna start off with the software. I'm using Candle to control the CNC machine. I have a Raspberry Pi running, communicating with the control board, and that's the CNC machine. These are the bits I'll be using. So this one is the one I'll be using for doing the isolation routing. This one will be used to drill a hole into the PCB, and this one is used to cut out the PCB by creating tabs. Okay, so we'll begin with the software. Right now I've already paired it up, so just go to Service, Settings, Service is up here. In terms of how it's going to work the same way, regardless if you're on Windows or on a Windows PC or perhaps even Mac. So this is a virtual machine. It's not virtual, sorry. Remote logged into the Raspberry Pi right now. So we go into Settings, and we'll see this menu. Choose the USB port that's connected to the CNC machine, and then set the baud rate to 115/200. This one is ignore error response. I untick this. You want the error message to pop up, but if by accident you click ignore responses in one of the pop-up messages, just come back to settings and disable this, and you'll be fine. These are all default values. I've not touched these ones. This particular string I copied from SaintSmart's tutorial. I'll be posting a link to where you can get that. Basically, this is used for the the probe mechanism to be used. That command is by default there. You can ignore these ones. These are commands that I made myself just for usage. If you're using probing, I suggest putting the probe feed to about 50. I found that to work quite nicely. Then after that, everything else is left at default. I've not changed any other configurations besides these ones, but these are just to display the commands being used. Everything else remains the same and unchanged. Okay. After you've made those changes, I suggest closing Candle and reopening again. Okay, so just to make sure that the CNC machine is connected to your computer, the status would typically be idle, and just to see if it actually is able to move, go to jog. So this is jog's menu. Just click on those 3 lines. It'll pop up like this. Then before you do anything, just make sure that the step is at a small amount, because you don't want to move it too fast. So it's at 1. And the feet I found for my one for CNC 3018 Pro, 500 was really good. So let's try it. So I'm going to press up, and the CNC machine is going to go up. Actually, no, sorry. This is the up button. So this is actually for the Z axis. As you can see, the notes that pops up, Z minus and Z plus. So if I press this one, it should go up 1 millimeter. There you go. So good, it's working. All right. Before we move on, I would like to show you my configuration. So if you have a CNC 3018 Pro, you might find this useful. So I'm just going to pause here for a second. Okay, sorry. So to get the configurations, just do $. Actually, I'm going to clear the console first. So this is just to clear everything that's on the console. Okay, now just press that. So the output of here is being presented. You can scroll up if you want to see it. I'm just going to copy whatever's in there. And then you can read it on this text file. Okay, so basically these are the configurations for the CNC GRBL software that's running on the control board. And the ones that I've changed are this one, number 3, $3, to 6, which basically changes the direction of the axis rotation. Inverts them is the proper way of describing it. Not sure if my bookmark's still there. I'll just show if it's still there. I think that might be it. Oh no, that's the height map. Let me just pause here and see if I can get the menu up. Okay, we're back. So these are I just went to GitHub, just type in GRBL configurations. So the one that I'm currently using is 1.1.f version. And basically, these are the settings for the GRBL configurations. So I'm just going to scroll up here so you can see it. So number 3 is saying that it's for direction, port, invert, mask. So you click that. This is basically the configuration to change direction of the X, Y, and Z axis. And basically just refer to this table above it. So to read this table is basically like this. So if you don't want to invert any of the axis, you set the value to 0. If you want to just invert the X, you just need to set the value of 1. And if you want to invert only just the Y, then you set the value to 2. And so forth and so forth. So right now I've set to 6, which is don't invert the X, but do invert the Y and do invert the Z axis. Okay. Just gonna scroll up a bit. Now I'm just gonna go back to the configuration files again. See if I can maybe make it bright. That's easier. Okay, there we go. Sorry about that. The next one is, I'm just going back to the text file. The next thing I changed is the settings for the rotations of the motor, which is 100, 101, and 102. The reason they are all the same value is because I'm using the same lead screw, the same stepper motors. So in terms of configurations, they will be the same. So let me see if I can bring that up back again. So 100 refers to X steps millimeter, so the X-axis steps per millimeter, and then 101 is Y steps per millimeter, and 102 is Z steps per millimeter. The following command that I did change is the 110, 111, and 112. I found that the default settings that came from a third-party vendor, which is from CronosMaker, they set the settings for this particular configuration to roughly 8,000, which caused my machine to stall at a certain time. So I changed the 110, 111, 112 to 500. So these 3 values. And that's it. That's all I changed in terms of
using, modifying the configuration file. If you want to know how to do that, it's basically just this. So I'm just clear that. So let's say, for example, I just want to change the X steps. So I just do $100 equals 800. So that's the value that I'm interested in, and I just hit enter, and that does it. It becomes like that. So usually when you press enter, it'll say OK. There you go. I typically like to restart my candle when I change any of the settings. It just comes back on. And that's it. So that's for the configurations. Now let's move on to actually setting things up. I'll pause the video here. Okay. So I made this, I 3D printed a PCB holder that is going to be attached onto the CNC's print bed, cutting bed, sorry. And basically I'm just going to put it in the slot here. It's going to be a tight fit because you don't want it to move. Okay, seems to be as much as it can go. I'm happy with it there. Okay. So this comes two pieces like this. This one goes up there, so you can see there's a bit of a different side. So what it does is that this is going to push it down like that and clamp it down. And within there you have your T-nuts. Here. Your slots nuts. And basically some screws. This design is not perfect, but it works, so I'm happy with that. I'm just gonna see if I can find my Allen screw. Okay, I'm back. So Allen screw, just tighten the bolts. Just find it here, fit it in there, give it a good twist to make sure it's gripping it, and just do it all full. Okay. Align it somewhere here, and just tighten all of it down. Okay, it's strong. It's not gonna go anywhere. Alright, now we're gonna insert our bit. So this is 0.2 millimeter tip. We're gonna raise it up as high as we possibly can. Alrighty. We'll try our best to fit this in there as high as we can into the socket. There you go. Just try to fit it as high as you possibly could. Is about there. It's best to leave a bit of room if you can, because this would basically be fitting around here. So you possibly just need to go down a tiny bit more. Yeah, about there would be good. Yeah, that would be nice. Okay, so just tighten it up by hand. Just hold the spindle here, then the socket goes in like this to tighten. Nice. Sorry, I didn't zoom in. There you go. So we'll just tighten the socket and it'll be something like that. Just to make sure that it's not slanted. Make sure that it's straight down like that. Once you're happy, use 2 wrenches. One holds here, and one goes at the bottom. Make sure it's got a good grip. Then hold this one at the top, and the one at the bottom, twist it tight to the right. Okay. And just release. You don't have to go super tight. Just sufficient friction will be good enough. Okay, there you go. It's good and strong. It's not moving. Alrighty. Now I'm gonna show you how to do probing setup. We'll go to here. So I have mine connected to this board, which is from CronosMaker. I made these this JST connector, and basically it's to connect to that pin there, which it says A5. So A5 is the signal from the board to figure out if it's there's continuity or not. So basically my probes are these 2 Aligator Clips. The black one's ground, and this one provides a 5 volts potential. Okay, so connect the black one to the PCB. Okay, sorry, I'm just going to zoom out so if you can see the whole thing. And then the yellow one connects to the spindle. Okay. Some people likes to put on the top of the tip over here. Some people like to do that. It still works because there's continuity from here to here if you just check it with a multimeter. But before we do all this, just to make sure that your connections on the board is good and fitting, and there's continuity there. I suggest, as a handy tool, always try to get a multimeter. For continuity tests, we're just going to be using this symbol here, and this is the setup for continuity. So ground, the common ground, and then the diode symbol there. Okay, so we're going to use the multimeter and probe. Most multimeters, when there's continuity, so if you touch each other, it will beep like that. It means there's current flowing through it. Now, just to show you there's continuity on the copper board, I'm just going to touch two sides. There you go. So there's continuity on the copper board. All right. Now, if you want to measure the continuity for the probe, you need to measure voltage. So, same setup. You're not going to change that. See, voltage, V, and grab. Move your multimeter to voltage. And then you measure the voltage. So, use any of the probes. So I usually use the black one, the negative, to the black Aligator Clip side here, and then the red one to the tip spindle, and you'll see a potential of 4.9 volts, around 5 volts. So that's good. It means that your Aligator Clips or whatever probe they're using is connected successfully, and there's no fault in the line. Okay. All right. So now we're going to do a continued test. So now we have that part set up. We'll go back to the software. I'll probably have to hold it. This out a bit. Okay, let's see how much battery I have left. Let's do what's the batteries. Cool. Now let's see. We're gonna jog the x-axis here, and we're gonna move the y-axis down a bit. There. Then we're gonna slowly lower the z-axis. So right now we're just going to try to do the setting of the offset. Sorry, these zeroing off all the positions. Okay, I'm going to cut the PCB around here. So I'm just going to try to find where it's going to be. I think there would be a suitable position. All right. So right now I'm just going to import my isolation route. So right there. So this is file that I've created previously, and choose the isolation. So this is after you've converted to Gcode by using a software. I use Flatcam. I might give a tutorial for that in the future, but for now, I'm just going to assume that you know how to use Flatcam. If not, I'll share a link of a tutorial that I found on YouTube. Here is the isolation routing. So this is my PCB that I'm planning to do the isolation routing for. Now, what I'm gonna do is to show you that this is where the 0, 0 position is, as in where the tip of this bit is gonna hit first. So right now, we've already selected where we want to cut. Now we just need to tell the computer that that's going to be the 0 point, the origin. So for this one, we'll click on this item to say that we want to 0 the x and the y position. So you can see 0, x, y. Okay. Don't touch this one. Ignore this one for the moment. Now, because we're using a Z probe, we can press this one, and what this does is going to move the spindle all the way down until it touches the copper board, and then once it figures out the height, it'll go back up. I'm just going to give you a 3-dimensional view of this so you can see the thing in motion. Actually, correct that. We'll zero the xy. Now we're going to 0 the z. Okay, so it's thinking it's there. Now we're going to do the probing, and it will redo what this did. So we're going to press this, and that's it. There we go. Just to show the animation that's occurring. So press this again. So it's going to go down, touch the board, and then come back up because it found the position already. And that's it. That's all you have to do. Okay. Now to cut PCBs, you will need to create a height map because the copper boards are not 100% flat. There are uneven surfaces. So we go to this option called height map. We click create. Okay. Once you go into the height map menu, you click auto. This will just basically create a red line border around your PCB. So my PCB is about 16 by 26 millimeters in dimension. The rule is that you take the number 15 divided by 10, which gives you 1.5, and then round it to the most significant figure, which is 2. This is 26.2 divided by 10 gives you 2.6. Round it to a significant figure, that's 3. Okay. So for the X, we put here 2, which is what we calculated. The Y-axis we calculate as 3. Put 3 there, and that's it. Then everything else, click show for all of them, and then all you do is click probe. So what it's going to do, it's going to go down and get points at each section to measure the height. And then basically the software compensates for the difference in height as your Gcode is running. So we do probe, and it's going to do 3 plus another 3. So that's 6 points it'll be probing. That's 1, 2, that's 3, that's 4, that's 5, 6, 7. Okay. So once that's done, it will say job done, time elapsed. Press OK. That's it. The probing is done. The height map has been created. You no longer need this. So before you do anything else, remove this once you're done with height map and probing. This one can stay on if you wish, but I don't need it. I'm going to yank that off. Okay. Now, come back to the software. We go to File, Save As, and this helps you save your height map. So you just do test.map, and we click Save. All right. Now click Edit Mode to get out of the height map menu, and then come back here, click Open, find where your map file is, and open that, and then make sure that you click Use Height Map. Make sure this tick box is selected, and then that's it. So double check, make sure everything's removed, everything's been positioned, and then all you do is click Send. I'm going to pause the video here for the moment. Okay, so now we have set that up. I'm going to click Send here. This button at the bottom of there. So height map's done, everything's done. Click Send. Things will start moving. And there we go. I'll show you the cleanup first. I'll clean up the rest at the end, but just to show you what it looks like. There you go. So that's the isolation routing part done. Now we're gonna do the drill hole. So I'm gonna pause the video here. Okay. Since we're gonna do the drilling hole, I'm gonna lift this up a bit. So make sure you don't home anything. Just move this by jogging the machine up. So go to the jog menu. Make sure this is a step 1 and just press up. Okay. Probably just go as high as you possibly can. I'm going to change this bit. Turn to the left hand side to loosen. That's right. Yep, there we go. Bits out. Put the drill bit in. Probably going to vacuum a bit more. Make sure this is not spinning anywhere else. There we go, it's tight. Coming out. Good. Okay. Come back to the software. Now we're gonna file, open. We're going to do the drill hole, so DRL. Open that one. So that's basically the operation of it. And all now we have to do is basically click send. So basically, technically, the software will go to where the 00 axis first and then start drilling. Because then you'll know where the origin is, because we've moved it up. But because we've already set where the 00 is based on these ones, it should be fine. Click send. And it broke my bit. Okay, so that means I didn't put the height high enough. But that's okay, I'll just have to buy a new one. Okay, now we're going to do the cutting out of the PCB, so we're going to move the Z-axis up so that we can replace the bit. Yes, it's broken, so that's pretty sad. I have to buy a new one, but still learning, so it's fine. There, goes here, and then turn left, loosen. This should just come out. So go check this out. So you can just see what it looks like at the moment. That's how the PCB is looking. There we go. Might be easy to see now. Okay. Next step is the cutout. So we're going to change it to this one here. Tighten it up. Okay, let's tighten. That's not coming out. And make sure that's straight down. Good. Okay. I'm going to pause the video here because I need to do a small change because I think I can figure out before my bits break again. Okay, we're back. Now we're just going to do the cutout. So click on the cutout Gcode. I'll zoom out a bit. There we go. Cutout Gcode. Open. So that's where it's going to cut. I make sure now that the end travel for the Z is at 5 millimeters rather than 0.5. So that hopefully will save my bit. I'm not sure. We don't have to do anything else. Now we make sure that everything's tied on and everything's in position. Bit's been changed, that's been tied in. Click send. PCB is done. Yeah, I'm happy with that. Okay, now let's go remove these ones. Go. Pop this out. And there we go. We got one PCB done. So we just gotta use some side cutters and pop that out. And you can clean that up with some sandpaper or just use your side cutters, and that's it. PCB done. Okay, so we're gonna start off with the software.